Okay, so today we are talking about text similarity and we will be exploring Trigram and UniSim. So, what is text similarity essentially? So, when you're trying to compare two different sentences generally, and you're trying to compare them to see how similar they are, generally the way you do it is checkout index. This is more algorithmic approach to doing this, where you have two sentences and you take the sentence, split it into smaller segments, and then you compare those two sets into finding out what is the intersection between those two sets. Uh, Generally, you don't want to do this over the complete sentence at a time, so you split those into smaller subsegments, and that could be word level, or even if you're trying to do word level similarity, you might do, or like character level similarity, you might break it into characters as well. One of the most popular methods in this process is called Trigram Scoring, where you take a sentence and split it into words, and then you compare three groups of threes on how similar they are. And again, similarity is essentially checkout similarity, where it's the intersection of the three words on how commonly they intersect with each other. Again, as I said, this is a very algorithmic approach. So let's see it in action here. So this is the Trigram Score function in here in Python that I've written it down. And then I've taken a query and a target. Both of those are exactly the same right now. So I'm trying to get a trigram similarity score. Of course, it's going to be 1. 1 essentially means 100 in this case. And because our scale is 0 to 1, so 0 would be 0%, 1 is 100% match. So for a second example, I took the same sentence and was just split it down into half, and we see our trigram similarity score is 0.5. For the third example, rather than splitting it into half, what I did was I took the key concepts from the query and used that to generate a trigram similarity score. It actually did not do a good job. It missed out a lot of context around it, but that was kind of expected because this is a trigram scoring where it only does algorithmic scoring. So it gave me 0.45 as the response. And similarly, when I rephrase the original text into something different, same meaning, but just the sentence has been rephrased into something else, the score is not similar or not high enough for it to be computing both of these as same. So Trigram Score has its usage where if you are trying to compare the accuracy of the written text between two different words or two different sentences, you're trying to compare them, how similar they are, just by the written text and not by the contextual knowledge. Trigram scoring is probably the best approach that you can go with. But again, it falls short in the terms of context around what you're trying to do, and similarly, it might not be a great example for anything that you're doing with machine learning, because generally a more contextual understanding based approach is more useful there. So for machine learning based approaches or questions, we have vector similarity. This is a really good blog post by Pinecone where they go into details around what does vector similarity mean. So essentially, I'm just going to summarize this into very quickly. You take text values, you generate them using a language model into vectors, and these vectors are the ones that you can use to find the distances between two different vectors. And these distances essentially give you how similar these are. So your query is trying to find the distance between multiple vectors, and based upon who is closer, who is farther, that becomes your similarity score. To measure the distance between two vectors, you have three different kind of metrics in here: Euclidean distance, cosine, and dot product similarity. And the article goes in more details about exactly how to calculate those and how to look at those. But essentially, that's how it works. You calculate the vector similarity and then use that as the distance to find out the best one that you could look at. Often, though, this is a more time-consuming process, and you generally want to create this data set, put it into, like, you have to figure out a lot of things around caching so that it's fast enough if all you're doing is trying to figure out a similarity score between sentences or between a set of data set that you have. So this GitHub project that is from Google right now, UniSim, it tries to do the same thing, but in a much more faster manner, and they go into details about exactly how they are trying to do it. They talk about RedSim model in here, and then on top of that, they're applying usearch to do fast vector searching in here. I'll probably make another video which goes more in depth about exactly how they're doing this, but in this example, I just want to show you exactly how it works. So just going down a little bit, to use this package, you just install the UniSim in here, and once you start to use it, it will try to load the backend. And since it's a machine learning based model, it would be great if it was running on GPU, but I ran this originally on CPU, so you can see that accelerator is not available, so it's using only CPU. Since we are on Colab, you can always connect to a runtime which has a GPU runtime, or of course you can connect to your local runtime as well, which you probably have a GPU on the local machine. So from here onwards, we go in and use the same queries, same examples that we did earlier, where we have the exact same query and target, and we try to get a similarity score. Now remember, this is a machine learning model, so it's probably not going to give you 100% similarity, but it gets very close, 99.99% similar these two are. Similarly, we go for just half the sentence, and just by half the sentence, we are essentially capturing a lot of details, a lot of context of the conversation. So that's why our score is 0.78. However, in your use case, you might want to look for this if you're looking for essentially if the sentence is complete. So your use case might vary based upon that, your application of which function do you use, UniSim versus Trigram, would vary. But the contextual part is important in here, and let's keep going on that, is if I take and distill down all the details within the text, within these two texts, it gives a high enough score. And even if I rephrase the whole thing and put it in a different way of saying the exact same thing, it gives me a high score in here too. And that's like really useful in cases of where you are writing a reply, or you're generating multiple different replies, and you're trying to figure out how common are those replies, how similar are those replies in the end, are they conveying the same meaning. So your mileage might vary, your use case, based upon your use case, you might have to figure out Trigram versus UniSim approaches. The team included a real world example. I'm not too fond of this, but it's a good example to at least go for. So let's go there and let's take a look at, like, the example here is a restaurant use case, where restaurant addresses are all over the place. Some people write the address in a different way, and you have gotten different addresses from different data sources. Then you might have same address labeled in different ways, and you're trying to figure out how same are those addresses. So the best way to do this in here, we load the whole data set and then try to find the exact match in here. This is the whole process to get to that. Like in the data frame, finally we have these responses, and you will see that there is a very little difference between these two. So these are very similar because it's Romolo place versus Romolo PL. Similarly, we have examples of street versus ST. I think there's another example here somewhere about the phone numbers where it was very similar, and similarly another street versus ST. So this you can easily see how close they are versus what the actual address is. One of the good examples that I can think of using this would be when users are typing on a delivery app or on a ride-sharing app, and users are typing in their address, and you want to figure out or match it to one of the predefined addresses that you have. You can easily take in their string, try to find the closest one, and give them the response. So this would be a really good place to start on this. This is all, again, Trigram Similarity versus UniSim. Your mileage might vary, and all the code is on GitHub right now, so you can play around with this. They released 1.0 version recently, so it's production ready. I've been getting a lot of value out of this, so just wanted to share this with you all. That's it. Thank you so much.